Okay, good evening, depending on where you're joining from. Oh, good day. So I've taken today's class, and it's basically the introduction to all this from layer tools to just setting up for this week. Then other classes would progress as we go. So yeah, let's wait a bit for more people to join. We have only 10 people here. So just wait for about 3 minutes before we start. About 3 minutes. Hope you all can hear me properly.
Yeah, I can hear you. Audio is great.
All right. Yeah. Can you see my screen?
Yeah, sure.
All right. So welcome once again to this class. So today will basically be an introduction to Cairo generally. So mostly talking about layer twos and just basically creating a foundation or a background for everything we're going to be learning over the coming weeks. So yeah, I welcome you all again to the first class, and hopefully we'd really learn a lot throughout this program. So I'll be starting out quickly to introduce layer two. So if you've been in the blockchain space for a while, you've probably heard of layer twos, probably heard of, like, just even if you know the meaning or not, you've probably heard people mention layer twos. So yeah, let's just go straight to what layer two is all about. So basically, the idea of layer two comes from this simple triangle. So basically, what this triangle means is this is called the scalability trilemma, which is basically kind of this triangle represents the fact that if one part of the triangle, if you're trying to achieve one part of the triangle, another one will lack. So everything has to work together for you to achieve scalability in the blockchain. So what does that mean? So basically, there are three things involved: scalability, decentralization, and security. So the question is this: how do you create a blockchain system that achieves these three things without compromising on any of them? So basically, how do you make the blockchain scalable without compromising on any of this? So you're talking about how do you create a blockchain that is scalable, that can scale with more transaction and can also be fast at the same time? How do you create a system that is truly decentralized? And how do you create a system that is secure without compromising each of this? So layer 2s are one of the solutions to do this because there are other blockchains. So, okay, yeah, basically, if you hear layer 2, then definitely there should be a layer 1, right? So it comes, if you say something is 2, then ultimately there's a 1. So layer 1s are basically the most of the blockchains, you know, so Ethereum, Bitcoin, Solana, and some other ones, right? So these are layer 1 blockchains. So now layer 2s came about because they were trying to look for a way to solve this problem, to make blockchain scalable. So layer 2s are one of the solutions that they came about because some blockchains say they're achieving these things, and some of them are doing it pretty well, some are not doing it very well. But basically, some layer 1 blockchains say they're achieving this. Some are faster, but are less secure and less decentralized. Some are not very scalable, but they are decentralized and they are secure. But yeah, layer 2 is a way to try to solve this problem. So yeah. So what are layer 2s? So layer 2s, there are different kind of layer 2s. So basically, the basic idea is that layer 2s are blockchains. Layer 2s are blockchains, not technically, because some of them are just smart contracts, but we are made to understand that they are meant to work like blockchains that are dependent on layer 1 blockchains, whether directly or indirectly. So there are a couple of them. So I think there are more, but we'll just be talking briefly on each of them. So we have channels, we have plasma, we have sidechains, and we have rollups. And rollup is the father of what we're talking about, like StarkNet and stuff like that. So let me briefly explain each of these quickly. So what are channels? So channels are a way to communicate or a way to perform transaction outside the blockchain. Then at the end of this set of transactions, you now return the final value to the blockchain. So basically, imagine you had a group of 10 people, all right, and you guys wanted to share money equally between each other. So you guys create a multi-sig contract, put in funds into the contract, and start transacting to each other. So when you transact, so now you're doing it based on trust, right? And you're doing it based on trust and based on the security of the channel. Now, so you're communicating with each other. This person sends, and you guys are doing it outside the blockchain. You guys are doing it off chain, right? You're doing it outside the blockchain. So at the end of everything, you now return the final transaction status to the layer 1 blockchain you're dependent on, right? So basically, you perform transaction outside the blockchain, then at the end, you bring the final result to the blockchain. So basically, one thing that you notice here is that you would have to do it among people that already know. So basically, the amount of people that participate.
No, I don't have money.
Sorry, can you mute your mic, please?
No, I have to transfer to the school.
Let me now to the period.
Have you finished the school?
Yes, now.
Can we find the
Yes, now.
Yeah, we are good.
Let's check first.
So yeah, so basically that's how channels work. A group of people who already agreed to perform a set of transactions, perform the transactions off chain, then return the final state to the blockchain. Then the way Plasma works is that they run independently of the blockchain, but they are anchored to the blockchain, the layer 1 blockchains. So basically, I have a blockchain running on its own, but it is kind of anchored to a layer 1 blockchain that's already existing. So they are not benefiting from the security per se because they have their own consensus mechanisms and stuff like that, but they are anchored because they have a way to bridge in and bridge out. So one issue between blockchains is that it's hard to communicate between each other. So let's say you can transfer a coin on Solana to Ethereum, right? But this kind of chains come with the benefit of having a bridge, right? Having a bridge. And also note that all these things are quite new. So people, like, a project might come up tomorrow and say they're implementing a plasma blockchain, but they might have a lot of things that are different. So, but basically these things are the basic ideas, because a lot of people have come up and implemented it a bit differently than others. So just take note of that. So these things I'm saying are not exactly how, I'm not saying this is how they should be, but I'm saying on a very basic level, this is what these chains look like. So then the third, which is sidechain. So one big example of a sidechain is Polygon. So the way it works is that they run on their own, right? They run on their own. They are not like, they don't have anything that, so they run independently, but they still have a bridge, right? They run independently. So the difference between plasmas and sidechain is that sidechain depends on the layer one somehow, but not on the security part, but they still depend on layer one. But sidechains run on their own, but they still have a bridge. So yeah, the two of them interact with the blockchain, with the layer one blockchains. They don't rely on the blockchain for security, because the only ones that rely on the blockchain for security is the channels. Okay, channels run on their own, sorry, is the rollups, right? But the plasma and the sidechains, they run independently, but they have a way to bridge in and perform send coins. Say you want to move your token from one blockchain to the other. So this is just a summary, and I advise you just read up more on them, because that's like the main goal for this call. But yeah, just read up on sidechains, plasma, and channels if you really want to check them out. Then the main focus, which is rollup. So basically, from the name, you would think about like bundling things, right? When you say rollup, you think about how do you like bundle stuff. So that's how it works basically. So what happens is that you have a set of transactions on another like, you can call it off-chain, you can call it your another virtual machine, but you depend on the Ethereum blockchain for finality. So what do I mean by finality? So you're depending on the layer one blockchain to be able to agree that this transaction is successful. So for instance,
Sorry, just power, please mute a family.
Okay, I'm looking for.
If you're the host, you can automatically mute someone, by the way. So you could just go mute whoever's talking, or whoever's mic is on.
Yeah, thanks. So yeah, so rollup. So basically, like I said, the bundle transaction outside the blockchain, but they depend fully on the blockchain to say that this transaction has been performed successfully. So that's what I mean by finality. So finality basically means at what point do you say that this transaction is completed, right? So if you look at transactions on layer one blockchains, layer two blockchains, you notice that they go in phases. So they have a phase whereby they are accepted on their own end, which is their own, you can call it the sequencer, just their own space to see transactions. Then it's now confirmed on the layer two blockchain. So that is the distinctive factor between rollups and a lot of these blockchains, meaning that they depend fully on the layer one blockchain for security. So yeah, let's just talk a bit about, I have another slide on rollup. So yeah, in a bit to effectively scale Ethereum, you have a numerous scaling solution, this. So basically, rollups have their own, like I said, they have their own VM or their execution context or their own machine. So they have a way to run transactions outside the blockchain. So you might have a rollup. You might have a rollup that's EVM compatible. So what I mean is that a rollup that can run Solidity, right? And they will have their own VM, their own EVM outside of the layer one blockchain. Then you can run transaction outside of the blockchain. Then you can, at the end, for you to see that this transaction has been successful, you would add it to the layer 1 blockchain. So now the name rollup comes from the fact that when you have, so from a high level perspective, the way it works is users send in transactions to the layer 2, to the layer 2 rollup. Then the transaction, they have a cap for how many transactions, the max transaction, number of transactions that they will have before it's been bundled up together and added to the layer 1. So basically, say we have the person in charge of, or the system in charge of taking in transaction takes in 10 transactions, right? And then you bundle this transaction, then you compress it. So very, very important. They compress this transaction to to be able to charge less on fee. So they compress this transaction, then they add it to the layer 1 blockchain. So that's very, very important. They roll it up and add it to the layer 1 blockchain. So yeah, types of rollups. So we have ZK rollups and optimistic rollups. So yeah, from what I have here, and so basically the way it works is optimistic rollups, the way it works is we assume, so from the name optimistic rollup, we assume or we're optimistic that these transactions are valid transactions until proved otherwise. So what I mean is, as transactions come in, there's this assumption that they are correct until another user or another let's say validate another node says that, like, or disputes that transaction. You understand? So basically this is called fraud proof, right? So basically, if you send a transaction or a list of transactions, it is the system is optimistic about the transaction, meaning that it's saying that, okay, this transaction it's a correct transaction until another user makes a dispute and says that, okay, he wants to, let's validate that this thing is actually true. Then there's a back and forth between these users and trying to prove it, sending proof and verifying and stuff like that. Then on the other end, using ZK rollups. So this comes from the idea that this list of transactions are sent, then using zero knowledge proofs, you're able to verify that this transaction is correct without actually revealing. So let me go back a bit. So first of all, ZK, which means zero knowledge, right? So the idea behind zero knowledge is basically, how do I prove to a verifier, or how do I prove to another party that something is true without actually revealing valid information, or just revealing anything? So from the name, zero knowledge. So zero knowledge, you're not giving any knowledge apart from the fact that this is true or not. You understand? So that's how it works. So basically, every transaction, you would basically you'd basically will prove that these transactions are right or wrong using zero knowledge proof. So basically using algorithms, zero knowledge algorithms, that will make sure that you won't get valid data about, you won't get important data about the transaction, but basically we can say that this transaction is true or is false before it's being added to the blockchain, to the layer 1 blockchain. So the big examples is Starkware and ZKs. So Starkware is a company building StarkNet, and StarkNet is one of these blockchains that uses ZK rollups. Then on the other hand, we have optimistic rollup, which is, the main examples are Optimism and Arbitrum. Yeah, so let's move to our next slide. So yeah, this slide is basically explaining zero knowledge. So let me talk more on that. So we have two major types of zero knowledge proof, right? We have ZK snacks and ZK stacks, right? So basically, the way zero knowledge proof, okay, let me just give you a very good example of how zero knowledge proof works. So then I'll try to explain why these two are really important at this particular point in time, and why they are deemed one of the best types of zero knowledge proof. So now there's this popular way of explaining zero knowledge proof. How do you prove to how do you prove to a blind person that two balls are of different colors without actually revealing the color? You understand? So basically, for instance, you have two balls, and based on the structure and based on the texture, they're exactly the same, right? But you want to be able to prove to the blind person that these two balls are actually of different colors, meaning that the person is seeing two of them as black, or let's say the person is colorblind, seeing each of them as black. But how do you prove to this person that you know that these balls are of different colors, right? So basically, how you're going to make this work is that you would tell the person to keep like switching the balls, right? So the person will take the ball to like hold the ball at the back. Then the person keeps switching the balls, but you somehow keep like you basically, the person would basically say, okay, this is the ball I want you to identify. So the blind person will tell you, this is the ball I want to identify. Then he starts turning it behind his back, right? So as he keeps turning it, you are still able to verify that this ball is this particular ball I want you to actually like this particular ball you're trying to hide from me, without actually, the blind person doesn't still know the color, but you just know, you're just trying to convince the blind person that this ball is actually of different colors, or they're actually of different colors, right? So this is the I think, I don't know if that's simple to understand, but basically this is the idea behind zero knowledge proof. How do you prove that this thing is, how do I convince you that this thing is this without actually giving you much information about that particular thing? Right now, an idea that is very important talking about this thing is the part of interactivity, right? So what is interactivity? Basically, when I explain this, you'll see that there's a back and forth, right, between the prover and the verifier. So there's a back and forth. I'm trying to convince, and we might have like 100 trials before the user is finally convinced that I know what I'm trying to say without actually giving them much, like any information, right? So basically, an idea that you'd see is interactivity, meaning that in a system that is meant to be fast, that is meant to be automated, you wouldn't need to be going back and forth, right? It would be a big flaw to be having to go back and forth, say using like proving things on the blockchain, right? You wouldn't want to have to go back and forth 100 times to be able to prove to someone something. So basically, the reason why ZK snacks and ZK stacks are really good is because they are non-interactive, meaning that I just have to create one proof and the verifier can validate the proof without having to get back to me, or without having to get extra information from me, or without having to interact with me back and forth. You understand? So yeah, so that's why these two have like really, really nice advantages because of, in fact, generally in computing or in using zero knowledge proof in computer science, you really don't want to be going back and forth, except you're doing it like the way I said, in a normal life scenario, right? So ZK snack, which means zero knowledge sourcing non-interactive argument of knowledge. Basically, the idea of sourcing, or the meaning of sourcing is there, means that it is fast, and it is actually it creates proofs of small sizes, right? Then ZK stacks are scalable, transparent argument of knowledge. So let's talk more about ZK stacks, because that's what StarkNet is built on, right? It's built on, like from the name, StarkNet. And just for more information, Starkware are like the company at the forefront of building the whole idea of stacks and stuff like that. Yeah, so from what we have here, ZK stacks are both non-interactive, like I said. Yeah, so there's this thing you'd find out when you're using ZK snacks, which means which is that they use something called a setup, right? A setup. So basically, you would have okay, basically it's something called a common reference string. Pardon me if you don't understand, I'm just trying to make more sense, right? So there's something called a common reference string, which means that during that trusted setup, so basically trusted setup is so that you'll be able to have a random value per se that will be used for the whole verification process and the whole proving process, right? So basically, when you want to create that common reference string, you have like a group of people coming together to create this proof, right? To create this common reference string. But now, what that brings about is like there's a breach in security. If they decide to compromise the system, in as much as it's called a trusted setup and a group of people, the system can be compromised because of you need people to actually come together. So not literally, when I mean people, you know, it's a automated system. So not literally people per se, but basically a group of systems to be able to come up with that particular reference string, right? So yeah, but the advantage that Stacks have over Snacks is that it doesn't use that, right? It doesn't use that. So see it here. In ZK Snacks, trusted setups are required and they are not resistant to quantum attacks, right? So, but say ZK Stack solve these two issues. They have drawback of large proof size, but they are created to be quantum resistant and do not require a trusted setup. Hence, they are more reliable. Like I said, they don't require a trusted setup. They are able to create proofs without having to create this trusted setup that where you have to bring up that people have to come together and create this common reference string. So also proof generations are also up to 2x faster, thus allowing for proof generation on smaller devices. Yeah, so that's that on ZK Stack. So also, if you have questions, you can just take them down. At the end, there'll be time for questions, please. So yeah, let's just go to Cairo. So yeah. So this funny meme, right? This funny meme is Rust is better. So yeah, this stuff is just comes from the idea that Rust is actually, sorry, when I mean Cairo is actually a bit, let me not say hard, but it's not intuitive when you think about, when you compare it to other languages. So it's not really hard per se, but it's not intuitive. A lot of things are not intuitive, maybe because of its close to low level. So yeah, I said Cairo, it's first Turing complete language for scripting, provable program for general computation. You should know that it is not high level language. So basically, if you start writing Cairo, you notice that a lot of things are closer to low level, right? A lot of things are closer to low level. So basically what it means is that you might have to write some commands that you probably be using commands that you'd are like close to the machine language rather than having to write. It's not a high level language, basically, that's what I'm trying to say, right? So, but they are like syntactic sugars, which is like the syntax is built in a way that even if you don't understand low level languages or you don't understand how memory and those things work, you would write it without having to think about those things. So yeah, Cairo is a language used to write scripting for scripting provable programs for general computation. So basically, Cairo is just a language. Let's just say Cairo is a language for StarkNet. Cairo is just like Solidity, but for StarkNet, right? It's like Solidity for StarkNet. So if you want to build on StarkNet, you'd have to use Cairo. And StarkNet is not EVM compatible, so you can't use Solidity on StarkNet. So you use Cairo, and it's built specifically to write programs that are for provable, right? Provable program for general computations. Yeah, so let's just I also share this slide at the end. So yeah, that's that on like the basic idea of layer 2s, Cairo and StarkNet, right? But now let's go into, I want to quickly talk about some of the tools you would need. Then I would just walk you through some of the tools that I would be using over the course of this course. So local development tools, we have one of them is Protostar. So if you're coming from the if you already write Solidity, one of the best like the best alternatives, so if you want to think about it in terms of relating things, so you can just say Protostar is like hard hat, but for StarkNet. You can also use hard hat on StarkNet, but for Cairo rather, You can go ahead. You raised your hand.
Yeah, please can you just zoom in your slide so can like if someone is complaining that it's not seeing the current slide you're on, can you just like make it full screen?
I think you should just run it as you run a slideshow, right? That would be better.
Yeah, just do a slideshow.
Okay. Oh, I think now
it's blank.
Yeah, it's blank. I don't know.
Click on the drop down and maybe you could start from the current slide. The drop down beneath the slideshow button in the other page, by the way.
I don't know why it's okay. Let me. Okay. And I think that's.
It's still blank.
Okay, I think we should just continue right the way it is. Because of time. Okay, this works.
And is this better? Because I didn't really do anything, just refreshed.
Yeah, let's just use this.
But basically, this like just trying to explain how that it's more practical than slides. So just pardon me for that. But yeah, I just want to talk about it quickly and just show you how to set it up.
Hello, I suggest the other man should zoom in from his end. You can zoom it on your phone without the presenter having to zoom it. So it's quite easier that way.
All right. Yeah, I think that works too. But yeah, so like I said, Protostar is just like hard hat, but for building on using Cairo, it helps you to compile, helps you to deploy, and yeah. Then Agent is like MetaMask, but for Starkware wallets. So so this idea implementing account abstraction that enables interact. So there's this idea of account abstractions, right? So let me just explain that a bit. So the way that works is you have okay, let's just explain how it normally works, right? So on Ethereum, there's an idea of there are two types of accounts, right? So you have EOAs and you have CA, so externally owned accounts and contract accounts. So what this means is that contract accounts are just contracts, right? They're contracts and they can call other contracts. You understand? But EOAs are just like our addresses. So just like the address you get when you create a MetaMask account and stuff like that. But there are some limitations to these things, meaning that the amount of things you can do from your account, like native to your account, is limited to just signing transactions, right? So let's say you want to create a multi-sig without having to use a contract that's already existing, right? So these are some of the drawbacks. You might want to, there's something called social recovery, where you have a way of retrieving your account when you lose it, which is not really common around like in the Ethereum space, which like if you lose your account, you've lost it, right? But now the idea of account abstraction is basically making your account a contract. So basically on StarkNet, accounts are contracts. So if you go to Argent and want to create a new account, they are basically deploying a contract that has some of these things for you. You understand? Like some of these things that you would not normally do, they have it inside of it, right? So that's just to clear that on like account abstraction in case you see it somewhere. So last thought we have StarkScan. So it's basically like okay, sorry. one other wallet for Cairo or for StarkNet is Braavos. So you either use, so let me just, so this is Braavos. So this is Braavos and this Argent. So but I'll still go over that, but yeah, these are two. So this, we have Argent and we also have Braavos, which are the two main wallets, just like they work similar to how MetaMask works. It was a plugin. I think they also have apps too. Well, yeah. So then StarkScan, it's basically like Etherscan, but for looking at transactions on the Ethereum, on the StarkNet blockchain. So looking at transactions there and seeing, yeah. Then another one, it's an alternative, is Voyager. Voyager, which has been really, I prefer StarkScan to Voyager because transactions pop up on StarkScan faster than Voyager. It takes a while for you to monitor transactions when you send them into the, so yeah, you can use any of these two, but I recommend this. So yeah, these are my accounts, and yeah, that's all for the slide. So let me just go through some of these things practically. So yeah, the first one we're going to look at is the Argent wallet. So don't mind this thing, these things are like, I'm on my local host, so this thing are fake this thing, Ethereum. So yeah, so this is just like okay, let me try to create an account so you see what I'm talking about. Let me try to create an account, a new account. And you see here it's writing, it's showing deploying, right? So it's deploying a new contract. Okay, go ahead.
Yeah, can you just probably show us so we can download the agent so we can just follow up with you?
Okay. Yeah, so just go to your store. So if you're using Chrome or using Brave, go to your Chrome store, or you can also go to your store for, I don't know if Mozilla has it, but if you're using Brave or Chrome, just go to the store for plugins and you'd get Agent, same as Braavos. So just type the name there and it should pop up. Yeah. So yeah, so you see when I try to create this account, it is showing deploying, right? So it's basically deploying a contract, right? Deploying a contract for you. So I would want to show you how the contract looks. So let me change to testnets, and let me show you a contract on Stack. Okay, view on StarkScan. So yeah, so basically this is what an account looks like. So instead of an account to be an EOA, like I said, and it's an owned account, it is a contract and it contains these functions, right? So these are the read functions. So it has get nonce. So you know the idea of nonce on an EOA, basically the amount of times you send transactions to the blockchain, so it keeps incrementing. So you have get nonce, you have the signer, you have the guardian, stuff like that. Then for the writes, you have a couple of them here. So initialize and stuff. So basically, instead of your account to be an EOA like on the Ethereum blockchain, it is a contract, and it gives you the ability to do more things. And you also have the flexibility to implement more functionalities depending on like if you're a wallet provider, you can decide to make this, add new, I don't know if there's a standard for creating abstract accounts, but as it stands now, you can basically implement any function you choose that you feel like would be good to allow users perform more stuffs on your wallet. So yeah, this is what an account looks like. These are the functions. Yeah, so then on using Braavos, so basically the same thing, but just different styles. So yeah, these are tests. Just these are tests. I'm on the test net. So yeah, so they have their main net. So this dev net is basically a local blockchain running on my computer right now. So yeah, these are just wallets for interacting with contracts or just making transactions on the StarkNet. So let me use Protostar to create a project. So we can just see how it works. Okay. Okay, let me share another part of my screen. Let me go into project. Yeah, so let me just let me share another part of my screen so we can just see how Protostar works. Not this. Also, I would still go through the chat to see the comments. So just in case you've been asking questions, I'll get to that. So yeah, let's just quickly create a basic Cairo project with Protostar. So let me just, you can see my VS Code, right?
Yeah, we can see it.
All right, cool. So
yeah.
All right, so then just quickly create. So let's just create a project called Test Cairo. I'm actually bad with project names, by the way, so don't mind me. Test Cairo. So yeah, I've already installed Protostar. I would drop the link to Protostar docs on how to install it on your computer. I'll drop the link on the chat, but I already installed it on my computer and just use it. But I'll send the link when I'm done. So yeah, let's just create a Protostar project, a basic project. So let's Protostar init. So basically, okay, asking us for a name. Let's just give it Test Cairo. I'm surprised I don't already have this name on my computer because these are the kind of names I come up with. So, oh, unfortunately, this. Okay, let me see if this works this way. Okay. What is this? Mistakenly stop my screen. Okay, let me share it again. Yeah, so yeah, we have this project. We have this project Text Cairo. So let's just go through what it contains real quick. So this the protostar.tom. So basically, this is just like a configuration file for your project. So you can like your version, your library, your contract. So as you create contracts, you add them here so that they'll be able to compile. So when you run Protostar build, which is for compilation, it's just the contracts named out here that will be compiled. The rest will be ignored. So as we create, we just put them here. So yeah, let's just go through the file. So these are tests. So if you want to write tests, so these are where your tests will be included in. Then this is the main.cairo, which is this is just where you write your code, right? As you create more contracts, as you create more Cairo contracts, you add them here, right? You add them here. So yeah, so this is where you write your Cairo code. Then lib. So basically, just like if you want to use, if you're creating a node project, you're creating a node project, and okay, if you're creating a node project and you want to install packages, so this is just like your node module. So it just contains all the projects that so you might install something here. So there are a lot, for instance, now things like this, things like this. Okay, this one's come natural, like normally, but if you say you want to use They are inbuilt rather. So if you want to use OpenZeppelin, because OpenZeppelin have a set of contracts, which we'll still talk about later in the coming classes, they have a set of contracts that would be using, because yeah, it's better to not have to bother about some of the things that they've already done, like security and creating some more contracts for us. So yeah, I would have to say if we install OpenZeppelin, would have to, it will be showing here, or we'll be seeing it here. So yeah, this is what a basic contract looks like. So let me try to compile this. Yeah, so we'll start build. Oh, we have an error. Not found. Okay. Okay, I think they created a subfolder for us. So yeah. Yeah, so it compiled successfully. And now we have this build, which normally you would have to ignore this with git ignore. So yeah, this contains the ABI. So the same idea of ABI, the same way ABI works in Ethereum on Ethereum, that's the same way it works here. So yeah, so this is the ABI used to interact with the contract. Then this is the contract itself. So the other values you need, apart from like other than the ABI. So they just these things are generated to be able to deploy. So when you're deploying, this is what you'll be using. This is the file you're using, because this contains details of what you'll be using to compile. So yeah, I think with that, I would stop sharing and go through the comments and yeah, that's it basically for today. That's it basically. If you have questions, okay, let me go through the chat and see. But yeah, you can unmute and ask questions, please, because I know I must have made some mistakes or something you've not been clear about. So just go ahead and ask, please.
I'd like to see what you do with the build folder once you compile your programs, maybe how to like interact with them in the runtime and start tinkering with them.
Okay, so right now, what I mostly use the build folder for is for deployment. So if I want to deploy, okay, let me try that. Okay, I think I've deployed the contract recently. Okay, let me share my screen again. I already stopped sharing. All right. So basically, what I use this for normally is to just deploy, right? But yeah, if Protostar gives us the ability to interact with these contracts without having to, like, for instance, there's another tool called StarkNet. StarkNet, like it's StarkNet. I think StarkNet compile. If you're using the generic guide listed on the documentation, you might have to use something, just some commands that are more, let's say, harder to use. So basically, if I wanted to interact with these contracts without using Protostar, I might have to use this individually. But yeah, what I use it for right now, okay, let me just search this out. Deploy. So yeah, if I want to deploy, so let me just click go back.
Is the chain ID a felt integer?
Sorry, I didn't get that.
I see the chain ID is an extremely long number. Is that a felt integer?
Yeah, so yeah. So how that works is the chain ID is SN_Gweli, but you have to convert it to integer. So it's a word, but you have to convert it to integer. So when you convert it, this is what you get. So yeah, it's actually it's a really long value. So it's basically,
yeah. In other words, I think it's a field, right? Yeah. That's SN_Gweli now converted to like Cairo's native data type fields. Yeah.
Okay, thanks.
How do you do the conversion, please?
Yeah, okay. I used it too. I just searched because I first converted it to hex, and I use it too. I just searched hex to integer. But yeah, you can just use tools like that. Just hex to integer on Google and just paste it, and you get the integer value, which is like felt in Cairo. Yeah, that's how you do it. But you can have your own custom tools. Like sometimes I use a Python code to just convert these things myself. But yeah, does that make sense?
Yep.
Yeah, is there a way you can put that in your config file to automatically convert it when you compile?
Convert what exactly? Because you would have to pass in. Yeah, you can actually add the chain ID to this file. Yeah, you can actually add the chain ID to this file.
Cool.
Yeah, thank you for that. Yeah. But right now I won't be using the chain ID, so I'll just add a network. So this is just I can also add that in this file too, but I'll just add that here. So alpha Gweli. Right, alpha Gweli. So yeah, basically I'm trying to deploy. So like I said, using the build the file generated in the build, you see I'm using this particular file. So if I try to deploy this, yeah, so it has been deployed. So yeah, so I use this file to deploy it. So that's it, yeah, basically. Does that make sense, bro? All right, I think.
Yeah, thanks.
All right.
I think Bob has the question, right? I can see his hands.
Okay, go ahead.
Hello. Hi, can you hear me?
Yeah, I can hear you.
All right, great. My name is Boy. You can call me Bob. I have two questions, and one of them is number one. I'm a smart contract developer actually, and I got a link to join this section from a friend that posted it on WhatsApp. And believe me, when you started, I don't know if there is a session that has been done previously, but my first time of coming in, I think there has to be some kind of an orientation. For example, what the whole training is all about, what it tends to achieve, then who are the target, is it for the newbies or an experienced developer? Because sometimes you go attending a session, I think a ZK course like this on Harmony, I think, yeah. And I really have a full good understanding of what ZK and all that is all about. But let me assume that I'm a newbie and I'm a new guy. I just started, blockchain development, and I came in, because we're already doing something like that are quite technical, which I think from day one, we're really not meant to go into that route. There has to be some kind of a good orientation on what is to be done. That's number one. I don't know if you can answer that first. Then I'll go to the second question.
So when you say orientation, is it what the course is all about or what you should use Cairo for? I don't know. Can you rephrase that?
Yeah, that was what I'm saying. Let's assume that I don't know much about blockchain development or Web3 development, and I'm hearing Cairo for the first time. The setups, all of that, how to go about it. I feel like a little was being said. This is just day one of the course, and we're already going to the more technical part of it, and I really do not understand much of what is done. So I'm trying to know that, okay, was there supposed to be a kind of orientation, like what exactly do you hope to achieve?
Okay. So I think when I was talking about the reason why you even have layer 2s in the first place, so I kind of did this top to bottom explanation up to Cairo. So basically why we even have StarkNet, right? Why we have layer 2s in the first place and why we use. So I said Cairo is a language for StarkNet, right? And we are learning about the programming language. This the reason why I talked about layer 2s and stuff is because I needed to create a foundation for all this. So yeah, this course is all about Cairo, and that's why I just told you what I basically did is how would you set up a project. I haven't written any Cairo code. I haven't written any code. I didn't even explain Cairo code. So I just basically I just did an introduction. So I don't think I did anything really like too technical, right? I just created a project for it. So does that answer your question or no?
All right, that's fine. If you feel you haven't done that, maybe I'm just misunderstanding.
Okay, Siri, please let me add something, right? Okay, guys, I just want you guys to
That's
know,
fine.
right? This is our first of this, right? This is just the first time we're organizing something like this. So at the end of the class, definitely we'll be providing a feedback form, right? So you could actually give your feedback and we could actually see ways we could actually improve the class going forward, right? Because we plan to have more of this. So yeah, I get your point about orientation, right? And I think the teacher, the speaker already, he did quite a good work at that. But I feel like okay, I mean you meant talking about how the class is supposed to be structured, the curriculum and the target audience and probably how it's going to run through the 7 weeks and
Exactly.
yeah. Yeah, I get
Exactly.
that.
That's
And yeah, we actually missed that. But thank you for bringing that up, right? We'll actually put that in the books and probably we can still talk about that, right? This is just 5:57. We still have about an hour to go. So I'll just hand over to the speaker and probably when he's done, Paul or someone else could come up and do that. But like I said, we'll provide a feedback form later and guys, please once you see the form of the group, please give us your honest feedback, and I think that's the only way we can actually improve and do better with the coming classes. Thank you.
All right, Darlington, thank you very much. So I think at the end of the class, I would go through the roadmap basically for the coming weeks. But yeah, thanks. So you said you have another question. Can
yes,
you go
please.
ahead?
Yes. Thank you. And from my understanding, I get to understand that Cairo is more of a low level language. And if you have to be something like a web application, web decentralized application, because from the other one we use in Harmony, if I could remember, we have to use something like a web assembly program, which is more also like low level language that has to convert between that language and to the web, I don't know, to the browser for it to communicate with the browser. Does that mean that we won't be needing any web assembly code if we have to use Cairo?
Okay, so are you talking about how do we interact with the contracts we are building?
Exactly.
From like a web interface. Okay,
Exactly.
so we'll be talking about StarkJS in the coming weeks, but basically StarkJS is a way to interact with your contract. And the way, like I said, using ABIs, ABI we use it here just the way we use it on Ethereum blockchain, on the Ethereum blockchain. So basically using our ABI, using StarkJS, we can create, we have ways to interact. So basically similar to how EthasJS and Web3.js works. You understand? So yeah, we can, once we have our ABI and we have our contract address, we can interact with our contracts using JavaScript or any other language that we have tools like StarkJS for. So yeah, you don't need WebAssembly, you just need the ABI and we can interact with it.
All right, that's great. Thanks for answering my questions. Thank you.
All right. Welcome.
Hey, I've got a cool question. What's the best IDE for developing in Cairo? Would you say which IDE has the best plugins? VS Code?
Yeah, so it's fairly new, but I think I think VS Code is like the default best. I haven't really checked the best, but yeah, I use VS Code for it. So yeah.
Cool.
Darlington, do you
Also,
have another option for it? Okay, go
wait,
ahead, go ahead. Yeah, I was asking my colleague if he had another. Yeah, he said VS Code too. Please go ahead.
Oh yeah, I was just gonna ask if there's any maintained Vim plugins for Cairo.
I think I found one, but I think I'll send it later. I think I found one for auto completion and code highlighting, but I would send that. I'll check and
that'd be
send that.
great.
All right.
Yeah, the one I found for syntax, I think isn't maintained. So if it's a different one, that would be great.
All right. I'll check that and get back to you. All right, I don't have any other question. Okay, let me go through the chat and see if there are any unanswered questions. And please, if you have any question, just feel free to unmute yourself and speak.
Will the only meetings be on Sundays? Say, for example, if there's like homework, or I mean, homework's kind of a weird word, but projects to work on in between classes. Will there be some like period for, I don't know, review or questions?
For now, it's only be Sunday. But if we change, I would actually communicate that. We understand like trying to review the assignments and stuff. But yeah, for now it's only Sundays. But we'll get back to you guys if we review that and change that.
All right, thanks.
Yeah, also I just have a suggestion, right? I don't know, Godspell, if you don't mind, could you maybe maybe briefly over the assignments, probably explain it, because I don't think there will be something like that this week, right? Maybe to actually better brains and do stuff now.
Okay. Yeah, let me go through what Bob asked about, which is the roadmap, and also I would talk about the assignment. So
Yeah, sure.
yeah, so this is the curriculum, just like the one we sent. It's exactly what we sent. So basically this week or today we talked about the introduction. Next week, let me just go through this. We're talking about the difference between a Cairo program, a Cairo contract, the felt data type, and struct storage values, and yeah, basically writing your first Cairo contract and the basic things you need to understand. So yeah, we continue that in the coming week, the third week. We'll talk more about some of the things involved in creating a Cairo contract: implicit arguments, hints and built-ins, error messages for user authentication, calling order contracts, a simple so if you check the documentation, you see this. This is one of the examples, one of the tutorials, a simple automated market maker. So just try to explain that. Also, just explain it in depth. So yeah, that's for week 3. So we'll go a bit into how it works, some of the whys, behind why it's working like this and why this thing is like this, revoke references, recursion. So right now on Cairo, there are no for loops, or there are no loops, right? So we use recursion right now, but in the coming version, I think the version Cairo 1.0, which will be coming out soon, there'll be support for loops. But right now, they're only recursions, and we'll talk about that. We'll also talk about writing tests on week 4. Then we'll talk about StarkNet.js. So basically, like Bob asked, this is what we'll be using to communicate with our contract on a front end, right? We'd create our front end and write code to interact with our contracts. Maybe not necessarily a front end, but basically interacting with the contract using JavaScript, right? So yeah, building dApps, like I said, we would build a minimal front end to test our contracts and stuff. Then we'll talk about bridging. So it's a layer 1, it's a layer 2, it's a layer 2 blockchain. So we'd have a way, would talk about how to communicate with layer 1, sorry. So basically communication, back and forth communication. Stargate. Okay, Stargate is a bridge for sending tokens between L1 and L2. So we'll just go through that. Then we find the final project. So just build. So let me go through the assignment for today. So okay, so this is just explain this. So I think this would be like an you can use a Google Doc or just use a doc to just write this out, explain zero knowledge proof and list their classification. So the more you understand how this works, you would be able to understand some of the things that we mentioned. So when you talk about writing provable programs, is from this zero knowledge proof, like you understand. So when you have more understanding about this, so you would be able to understand some of the whys even beforehand. So yeah, ZK gives out the same vibe as ML. More people keep mentioning it's like all right. So basically, what are some of the applications of ZKPs, right? So what are the applications of zero knowledge proof? So I know we talked a bit about this on the call, but just do more research on why you think, what are the advantages between StackJS and SnackJS? Sorry, stacks and snacks. So the two types of zero knowledge proofs, or the two main types of zero knowledge proofs. Yeah, so basically you would just redo what I did, right? So just deploy a contract. I deploy it on AlphaGoeli like I did. If you install Protostar, the AlphaGoeli will be in your computer. So yeah, you can just use that. It's a default value, so you can just use it, and once you use it, it's been deployed to the AlphaGoeli stack and testnet. So yeah, so that's what the assignment is all about. Any questions?
How do we make a submission for the assignment, and when is the deadline?
Okay, we'll communicate that to you guys after the call. So we haven't taken that down, but we'll communicate immediately after the call when the deadline for the submission. But yeah, thanks for that. I would create a form to take in the assignment.
Just
Okay,
wondering,
thank you.
I saw that you have the resource for sharding on Vitalik's blog. What's the value in understanding sharding for StarkNet?
Okay, so that stems from the idea that sharding was one of the proposed mechanism for scalability on the Ethereum blockchain. So it helps you understand why the idea of scalability and why they even need scalability in the first place. So sharding was one of the ways that they proposed. I don't know, it's not currently implemented, and I think they moved it. I don't know if they're still working on it on the Ethereum Foundation, but basically it's one of the ways they propose to be able to scale the Ethereum blockchain. So it helps you understand the idea of scalability.
Gotcha. Yeah, for understanding data sharding, that makes sense.
Okay, yeah, just to add to that, right? Like sharding currently, right, is not yet implemented, but I don't know if you've heard of EIP 4844, right? Proto-Dank sharding.
Yeah.
So that's going to be very useful to Rollups, right? The whole idea is we get to replace the core data type with a blob data type, right, which can help Rollups to save a lot of gas costs, since core data are like super expensive. So you could just read more and read up on Proto-Dank sharding and the EIP 4844, right? So I think it's currently on that way, and I think it has a whole lot of extra benefits to Rollups and StarkNet in general.
Yeah, big fan of Dankrad Feist. Thanks though. Thanks.
Yeah. So does anyone have any other question about the curriculum, about the class?
Okay. Just to add to what Gospel and Darlington said, for the week 4, I mean, he has gone through the whole curriculum, right? But then for the week 4, we are going to have developers from the StarkNet team to join. So we are actually looking forward to that, right? They're going to like be joining one of the classes to help as well to educate everyone as well. So we're actually looking forward to that. And for the assignments and all, we will communicate that in the group, just like you said. We'll communicate that in the group, so you can have like a response before the next Sunday.
Yeah, thank you for that. So
okay, and as well, if you learned something today, you can tweet it out. Definitely will retweet like the best comment to post on Twitter. And also, if you when we like go forward, definitely if you learn more things, like you can definitely like post on Twitter or retweet the best ones and all.
Wait, should we send submissions like over Telegram or over Twitter, or just post them on Twitter and you mean you'll retweet them? What do you mean?
No. I'm just saying like for the assignments, that one is different. We're going to like send a submission form, right? I'm just saying that probably if you learn something, you had to call our classes, right? You can always like share on Twitter and definitely repost.
Oh, cool.
Yeah.
yeah.
Okay, I think we actually must close up end of today's classes, right? And definitely just like introduction. So I didn't actually expect it to like consume the whole 2 hours we have for today. But then for upcoming classes, I expect it to be more lengthy, right? So if you still have any other question, like any question, you can definitely ask now. So before we come to the end of today's class. Okay. Okay, thank you all for joining today's class. We're going to send out the submission form for assignments via email or via the group. I think email actually gets everyone. And as well, the recording for this call, we're going to still post it out, right? In case if you want to like revisit them. And yeah, we are hoping to like have more classes and like this interactive classes. So if while you like for the next class, just try and attend to the links that we posted for week 2, so you have like more questions to ask, right? So it will make it like more interactive and more interesting for us to attend to these questions. Okay, thank you all for joining today's class. See you all next week Sunday.
Bye, guys. Take care.
Yeah, at the same time, 5 p.m.
Yeah, thanks.
Yeah.